Welcome to 10 minutes CS. 2044 count number of maximum bitwise OR subsets. Given an integer array nums, find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets with the maximum bitwise OR. So first of all, we have to find the maximum possible bitwise OR of all the subsets in the nums. The subset definition is given as follows. An array A is a subset of an array B if A can be obtained from B by deleting some, maybe 0, elements of B. Two subsets are considered different if the indices of the elements chosen are different. So let's say we have 1, 2, 3 as nums. So one of the subset can be 1, 2, the other can be 2, 3, one can be 1, 3, and 1, 2, 3 is also a subset. So all these are subsets of our set. Now we need to find the maximum bitwise OR of all the subsets of nums. Now let us take this same example as 1, 2, 3. So bitwise of 1 will be 1, for 2 will be 1, 0, for 3 will be 1, 1. Now what will be the maximum OR of all these? If we observe carefully, if we will OR all of them, then we will get our maximum bitwise OR because 1, 1, 0, 1, 1. Now what would be the OR of 1, 0, 1? That will be 1, and 1, 1, if there is nothing, that means it's 0, that is 1, which is exactly same as OR of these two and doing the OR of resultant with the next one. So to get the maximum bitwise OR, we can run a for loop and get an OR all the elements and get the maximum bitwise OR from that. Why does this work? That for getting the maximum OR, we can do the OR operation of all the elements, because what is a OR operation do? So let's say we have 0, 0, 0, 1, 1, 0 and 1, 1. For all of these instances, only when both of them are 0, we get 0, else we will get just 1, 1. So what will be the maximum OR of any element is when we get all ones in all of the positions. So if any of these positions have either ones 1, that will give us 1 in itself. So that's why we can OR all the elements and get the maximum OR that we can obtain by doing it for any of the subsets. Now the second part of the question is, we need to return the number of different non-empty subsets with the maximum bitwise OR. So for this, we can either find all of the subsets and get the maximum bitwise OR of it. So how will we find all the subsets from our nums? So for this, a simple template will be, for any of these indices, we can either take these indices in our subset. So if we will take it, then we will have 1, 2 and 3, and if we won't take it, we will have the other 2 and 3. Similarly, we can do for the rest of the indices. So that's how we will write our code. We will first use a take and not take, and among all these, whatever number of subsets we get for which our OR is equal to our maximum OR, we will return them. So we will add take and not take from here. Now what will be the base case for it? As we will be sending our index I and we will be checking for this I. So at the last, this I will become out of bound. So if it is out of bound, that means our I is greater than or equal to the n, where n is the nums.length, and we will check if our current OR is equal to max OR. In this case, we should return 1. That means we have got one subset which is satisfying this condition, else we will return 0. And how will we check for our take and not take? Let's say this is our function, which is our subset function. So in this we can pass, first is our array, then our index, and then our maximum OR, and what will be our current OR. Current OR will be nums at I or with the current OR which we have. And for the not take, everything will remain same, just that this will be current OR itself. We won't be changing it. Right? Now, can we optimize it a bit? So here, what are the changing variables? Here I is changing and the other is the current OR which is changing. So we can take a DP, a 2D DP, whose first index rows will be denoting our I and this will be denoting our current OR. Now, how far can our current OR get? It can go to max of max OR, and our I can go up to n. So, and from here we can check if our DP value is not equal to -1, then we can just return itself, else at the last we will be populating our DP using that same function. Now let's look at the code. Following up on same idea, we have our max OR which is initialized to 0, and we will be getting over every element in our nums and populating our max OR with the max OR or with the ith element. And here we have initialized our DP with our nums.length +1 and max OR +1, and we fill it with -1, and then we call our function to get all the subsets. So here we have our so our base case will be, we will check if our ith index has gone out of bound. If that's the case, then we will check if the current OR is equal to the maximum OR. If that is true, then we have got one of the subset, so we will return 1. If this condition isn't met and we have reached the last of our index, then we will return 0. Now we will check if we have already found this value in our DP, so we will return our DP value, else we will do our take and not take approach, where we keep on incrementing our pointer with increasing the nums current OR with the nums I or with the current OR if we are taking it. If we are not taking it, then our current OR remains the same. And finally we will return our take plus not take value, and we will add it to our DP also. So what will be the time complexity for it? Here we are going up to maximum of n cross max OR states, right? So this will be our time complexity, and space complexity will also be same as we have DP array. Thank you for watching.